Okay guys, we're going to do another Kirchhoff's law problem. This one is with more batteries, and instead of finding the current through each branch, we're finding the resistance or the voltage drop across R4. So in order to find that, we need to find the current through that branch. But then once we have that, it's just V equals IR. So it's just one tiny more step. Alright, so first thing I'm going to do is I'm going to draw the arrows in the batteries. Remember, the arrows in the batteries always have to point toward the larger end of the battery. That's the way they're pushing the current. Everybody remember that?
Yeah.
Yep.
Okay. Oh, what's R2 here? I have to add that one.
18.
Okay, so now we go through and we add the currents. And again, it doesn't matter what direction we put them. If you always want to do them like this, that'll work. So I'm going to start with I1 going in. I'm going to have I2 going that way, and I3 going that way. So we're doing this junction right here. Okay, so what's our first equation based on those currents?
I1 equals I2 plus I3.
Yep. So we got I1 equals I2 plus I3. Alright, you guys want to do the top or bottom loop first?
Bottom.
Bottom.
Bottom? Alright, we'll have it go
Bottom.
around like that. I usually draw them whatever way the bottom battery is going, but that's just me. So you can draw that loop either way again, but you can always draw it this way if you'd like. So we'll start at the 61 volt battery here. Nice random number. What is the, is that going to be positive or negative?
Positive.
Why positive?
It's going the same way.
It's going the same direction as the battery. So the battery is pushing current this way, the loop down there is pointing that way, so it's going to be positive. For batteries, remember, if it is the same direction, the battery is positive. If it's the opposite direction, it's negative. Okay, what about this resistor?
Opposite.
Positive. Negative. That's positive.
It's going to be
going the opposite way,
positive.
so it's
Positive.
So for resistors, if the current through that resistor, so in this case I3, if it's the opposite direction of the loop, we make it positive. If it's the same direction as the loop, we make it negative. So again, for resistors, if the current through that resistor is in the same direction, we subtract. If it's opposite direction, we add. So these are opposite directions because the loop's pointing this way at this point, and the current's pointing that way. So you're going to add I3 times 18 ohms. Questions about that one? Okay. Next up, we have V2 here. Add or subtract that one?
Subtract.
Subtract, so we're going to do, because the battery's pointing that way and the loop's pointing that way, we subtract 25 volts. Alright, 20 ohm resistor here. Add or subtract? Add, because the current's pointing that way for I1 and the loop is pointing that way, so we're going to do plus I1 times 20 ohms. And last one down here, the 11 ohm resistor.
And you add it.
We add it, the current, if you kept drawing I3, it goes like that. So the current through R1 is pointing that way, the loop is pointing that way, so they're opposite directions, and it's a resistor, so we add. So plus I3 times 11 ohms. And we could have actually combined these two resistors and done it in one step, but that's just kind of another extra step. I don't know if you guys want to do that or not. Okay, so that's the bottom one. Alright, so for the top, we draw it like that again. So we get 0 equals, are we going to add or subtract V2?
Add it.
Add it. So 25 volts is in the same direction as our loop. So the battery's pushing it that way, the loop's going that way. So we have 25 volts. What about V3 there, the next battery? Subtract because battery's pointing that way, loop's pointing that way. So we do minus 35 volts. R4, we're gonna add or subtract?
Subtract.
Subtract because it's in the same direction. So if it's a resistor, we subtract. So it's gonna be minus I2. The finger's not working. I2 times 10 ohms. And last one on this loop, R3. What's that? Add or subtract?
Subtract.
Subtract, because again, current's going to the left here, and the loop's going to the left in that bottom part. So minus, and what current are we going to use? I1, 2, or 3? Oh,
2.
for R3?
I1.
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 So I1 times 20 ohms. Questions so far?
Actually, there.
Alright,
I want to do that right
now we want to solve these two equations for R1 and substitute back in. So I'm going to start with the bottom one there. So I'm going to bring everything with I3 over to this side. So it's going to be, we're going to subtract this term and this term. Does that make sense to everybody? Actually, I'm going to scratch that. I'm going to bring everything else over to this side. That way we don't end up with negative I3. So I end up with negative 61 volts minus plus 25 volts minus I1 times 20 ohms equals 29 times I3. Everybody with me on what I did there? Everybody okay?
Yep.
Okay. So let's simplify a little bit more. Let's simplify this term. What's 61 or negative 61 plus 25? Negative 36 volts minus 20 I1 equals 29 I3. We get I3 equals, what's negative 36 divided by 29?
1.24.
1.24 minus, what's 20 divided by 29?
Does it matter?
What is it?
It's,
Oh,
does
thank
it
you.
matter if it's negative or not?
Should be negative, I apologize.
And then it's 0.69.
0.69 I1. So that's our term for I3. Questions on anything we did there? Alright, can I erase that? Is everybody good? What do we get? 36? Negative 61 plus 25.
I went to the top one.
Sorry, yeah, we brought this one down. Can I erase now?
Yep, you good.
Alright, now we're going to do the top one.
Excellent.
So again, I'm going to bring I2 over this time since it's negative, so we get I2 times 10 ohms equals, what's 25 minus 35? Negative 10 minus I1 times 20 ohms. Divide both sides by 10, we get I2 equals negative 1 for 10 divided by 10 minus, what's 10 or 20 divided by 10?
2.
So 2 I1. That one worked out nice. Questions about that one? Alright, And this hat's getting really hot.
I was gonna ask you about that.
You can do
I want to
it.
start wearing hats every day. I think it's something I can do. Alright. So now we gotta substitute into I1. So what was I2 equal to?
-1 minus 2 times I1.
Negative 1 minus 2 times I1 plus what was I3 equal to?
Negative 1.24 minus 0.69 I1.
Minus what?
0.69 I1.
Okay. Now we gotta solve this thing for I1. So we get, add these two to each side, we get 3.69 I1 equals negative 2.24, is that right?
Yep.
Okay. And what does I1 end up equaling?
Negative 0.61 amps.
Negative 0.61 amps. Alright. Questions about that so far? Now, which current do we actually need to solve for the voltage through R4? Top, so I2. So we don't actually need to solve for I3 in this one, we just need to solve for I2. So what does I2 equal?
Negative 1 minus 2 I1.
It's 2 times
I1.
I1. So we say negative 1 minus 2 times negative 0.61 amps. What's I2 equal to?
Wait, 22 amps.
0.22 amps. And now we do V, separate this off, equals IR, V equals 0.22 amps. And what's the resistance that we're looking for?
10.
10.
10 ohms. So we get V equals 2.2 volts is our answer.
That's cool.
Questions about that one? Make sense? Right. I will turn off the video now. And why don't you guys try doing the one in the back? It's kind of the same deal. It's a little bit easier though.
Yay.